We're now going to explain the fundamentals about power and electricity. We'll be talking about voltage, current, resistance, and electrical laws. Voltage is the difference in electrical potential or energy between 2 points of an electrical or electronic circuit, expressed in volts. It's this voltage difference between any 2 points that forces a current through a conductor. The voltage can be generated by different means: chemically, in batteries and accumulators; mechanically, in generators; directly, in fuel cells and piezo generators. The EMF is measured in the unit volt and has the abbreviation U or V. You can measure voltage or potential difference between any 2 points in an electric circuit. But usually it's best to have a set reference point. This reference point is called the earth or the ground. It's generally considered that the reference point has a zero voltage. If you connect the negative pole of a 24-volt battery to the earth, you consider the positive output of the battery to be plus 24 volts. If you connect the positive pole of a 48-volt battery to the earth, you consider the negative output to be minus 48 volts. Current is considered to flow from the positive to the negative pole of the voltage source. Now, in reality, a current is a flow of electrons that flow from the negative to the positive pole, the opposite direction. Current is generally represented as I and is measured in the unit ampere. Resistance is a measure of opposition by an object to the current passing through it. The higher the resistance, the lower the current. The unit of resistance is ohm. A current passing through a resistance will result in a voltage drop across it, which can be measured using a voltmeter. The relation between voltage, current, and resistance is called Ohm's law. Ohm's law states that the current flowing in a circuit is proportional to the potential difference across its terminals. All cables have some resistance. This will cause a loss of energy and dissipation of surplus heat in the cables. If the current through the cables gets too high, it'll heat up, causing the insulation to melt and resulting in short circuits. So, the cable's size has to be designed in relation to the current. There are several factors that will affect the maximum permitted current, such as room temperature, insulation material, and so on. Those calculations should only be made by certified engineers. For example, the formula shows that a thinner cable has higher resistance, and in contrast, the thicker cable has a lower resistance. When working with battery cables, make sure that the cables are double insulated. The way cables are tightened and layered together is also crucial in terms of their current carrying capacity derating factor. For example, coiled power cables must be current carrying capacity derated due to accumulated heat. As we already mentioned, all cables have cable resistance. The longer the cable, the higher the resistance will be. This will cause a proportionately higher voltage drop. Now, voltage drop is a more important factor at high currents. Power is the rate of flow of energy and is calculated as the product of current and voltage. It's measured in watts. The symbol for power is P.